Hi, my name is Melissa Bates. I'm with the U.S. Department of Energy. I'll be presenting the CINR scope for the integrated energy system. I'm the federal program manager, but Shannon Bragson is the national technical director of this area. So what is integrated energy systems about? With the development of solar energy and wind energy, they've been integrated into the network, and what it's doing is in these networks or in the grid system, when solar energy comes online and ramps up in some regions of the United States, it drives or it increases the demand. Sorry, it increases the output of electricity generation and drives down the actual price point for electricity. For baseload generators like nuclear power plants, coal power plants, natural gas, given this price point that drives down, it can drive down below where they need it to be economically viable for the plant, and sometimes can even drive to a negative price point. And so in order to improve the efficiency of the electricity generation for these baseload generators, as well as to work with wind and solar energy, we are trying to reimagine how energy can be used. Today we have a system where you have electricity generators that are producing electricity, and it goes out when you turn on the light switch. There's a much more efficient way of running the system, and that's an integrated energy system. You can partner with wind, solar, coal, natural gas, all of them, and basically do analysis such that when the price point for electricity drops below a certain level, the electricity generators can use the solar, but the other generators can move over to a different commodity that may get more economic value, like hydrogen or clean water. So with this year's CINR scope, we are focusing on the clean water aspect of this program. Recently, there was this White House initiated activity where they're working for entities to develop advanced transformational technology to produce safe, secure, and affordable water. Here's the 5 goals for that program: launch desalination technologies that deliver cost-competitive clean water, transform the energy sector's produced water from a waste to a resource, achieve near zero water impact for new thermoelectric power plants, and significantly lower freshwater use intensity within the existing fleet, and double resource recovery from municipal wastewater. The last one is develop small modular energy water systems for urban, rural, tribal, national security, and disaster response settings. So those are the 5 goals that are under this Water Security Grand Challenge. And then there's more information at that link. Given the focus on integrated energy systems and that we're trying to partner with wind and solar and other generators to produce, hydrogen or desalinate water, we're more interested in these specific 4 goals here on the slide. And since I just write them, I won't reread them. However, in doing these, like maybe one example could be using, a advanced reactor to purify water, in a certain region, using that thermal output. Or there's other examples that are out there. What we're not looking for is for entities to be proposing new reactor designs that are novel. What we're trying to do instead is to take a reactor technology that's already out there and to implement it or propose a system or a project where that reactor technology could be used with a novel coupling technology or system control or an optimized operational dispatch, for the production of water and electricity production. Some other things to consider. Cyber-informed engineering should be considered in system design, dispatch optimization, and system control. Computational models should be capable of integrating with Modelica and Raven-based ecosystems for modeling and analysis that is used by the lab team for integrated energy systems. The systems of interest could be applicable to fixed installations or could be modular or transportable. And then principal investigators are encouraged to investigate the potential markets and market competitiveness for proposed solutions within large-scale centralized grids or islanded microgrids that may be applicable to SMRs or microgrid technologies. So that's it for my presentation. Are there any questions?
If attendees would please use the GoToWebinar application to type in their questions, then we'll ask the questions in the room from Melissa. We'll wait a few seconds until a few might show up. What TRL do you require in the technologies proposed, excuse me?
I would say that there's probably not a specific requirement for a TRL level. Obviously, the further along it is, the better, because then it'd be closer to, actual deployment or commercialization. However, I think, especially through a university program, we're interested in, if someone has a great idea, we're interested in hearing it.
Is the call for experimental work or modeling?
Both.
Are Generation 4 reactor systems considered?
Yeah, I would say that they are. We're fairly flexible, so long as someone has a novel idea for how to integrate nuclear with the integrated energy system for water production. Yep.
Should the considered existing reactor technologies be U.S. reactor technologies, or is coupling with a non-U.S. technology in the scope?
Yeah, it would need to be a domestic reactor technology.
We'll wait about maybe 20 seconds to see if any more questions show up. Okay, I think that's all the questions we have today.
Okay,
Thank you.
Thank you.